Well, hello and welcome to our midsummer edition of Dozers to Drywalls. We had our sessions with various people throughout the school year, and when summer hit, we haven't done anything in about 6 weeks, or maybe even a little bit more, maybe more like 9 weeks. But right now it's the middle of summer and middle of July actually, and I thought we ought to try to throw together one podcast at least. And I walked through the building last week and I was here. And I found Professor Heidarinejad. And if I butchered your name, I apologize.
No worries.
My one job I had at CNA, I was so bad on names that every time I said somebody's name, my boss would say, "Okay, Roy."
That's a good one. Yeah, yeah. I
said,
like it.
I said, "All right, who did I call by the wrong name this time?" But it was kind of a running joke in the company. But Mohammed's been with us here for how many years, Mohammed?
It's been almost 8, 9 years. I started in January 2018. Wow, long time ago.
Well, that's good. And you're a favorite here.
Thank you.
Uh, just so you know, I don't know what got into me, but I asked the AI 2 days ago for famous quotes of IIT professors, and it came back and said, "We're in the CAE department. What years do you want?" And I said, "Well, since 1983," and it's went through everybody. And I think what it did is it went to students' notes that they posted, and I can't remember the one that came up for you. I'll look it up. But for mine, it said, uh, and I don't ever remember making the statement, it said, construction is simple, people are complex. And so it has these, if you want to look yourself up for your famous sayings that you don't even know about, they're out there, Mohammed.
That's good. I haven't tried it yet. I'll definitely take a look. I mean, you have been here like for 3 decades, is it correct?
I think this is 39th year.
So probably like for every decade we get one quote there. So I'm getting close to that.
Yeah, I came here actually as a student in '83.
That's amazing.
So, and I started teaching, I think 6 years later. But yeah, that's the way it was. But you're a key, an absolute key in our architectural engineering program, right?
I hope so. I mean, yeah, I started I can also talk a little bit about my background. So
Sure, go ahead.
I graduated, my undergrad was in mechanical engineering, but at that time I was very interested in buildings, knowing about like buildings, how they operate, knowing about their mechanical system. So kind of I went through that direction. And then for the grad school, I did my master's in architecture engineering, and the PhD was in mechanical engineering, but the focus was on building energy efficiency and air quality, indoor air quality. So I graduated around like 2014, long time ago, and then spent a few years at the University of Maryland College Park as a research associate there. And then I was very interested to join a program that they have architecture engineering, but I'm very passionate about architecture engineering. I believe it's a good blend of different engineering disciplines. So when the position here opened it up, I applied for it and I was selected for the position. So I joined 2018, started gradually getting into the program, like teaching different courses, helping with the program. When I joined here, we didn't have a PhD program. So with my colleague here, Professor Brent Stevens, we established a PhD program in architecture engineering. So I would say we are probably one of the few programs in the US that we offer undergraduate, master's, and PhD in architecture engineering. So passionate about it. Now at the moment, teach about 3 to 4 courses per year, helping a few other courses, and also like offered a few elective courses. So I would say, yeah, I helped the program a little bit and part of the program.
And we kind of have a little bit of differences in our audiences. We have obviously People who are working out there are alums and other people that know a lot about it, but we also have the people that are looking to come to school. And hearing the term architectural engineer, just to make a very quick explanation for those people, is the history of architectural engineering is in Great Britain. The architects didn't want to be bothered with the engineering part of a building, so they created this profession called architectural engineering. And as it evolved in there and in other places through the British Commonwealth and also to here, uh, buildings also became automated from the days when we had open windows for air, and then we got HVAC systems and that. So an awful lot of what architectural engineers do is very similar to what mechanical engineers do in a heating and cooling system. And except in today's world, it has just become so computerized that it's an entirely different world. Would you say that?
Yeah, definitely. I mean, yeah, you summarized it well. Architecture engineering, it's a program that maybe requires, as you mentioned, a little bit explanation what it the program entails. So I would say if you're looking at engineering, it's very comparable to mechanical and civil engineering. Like our students take the same level of physics, calcs, all of those. The difference is we define architecture engineering to focus only on the building. So we look at building systems. So the difference between the mechanical, as you pointed out, Professor Lemming, is we take thermodynamics, fluid mechanics in architecture engineering, but at some point we take it further, looking at it from the building science perspective. It's a required course for us. HVAC system design, again, another required course that I usually teach that course. We look at it from fire protection and plumbing. So students get to know both fundamentals and applications because a lot of time these designs, you want to look at the code, you want to comply with that. So that would be a major difference between the mechanical engineering and architecture engineering because mechanical engineers might be definitely better from part of the fundamentals, but they lack the application side. Similarly with civil engineering, like civil engineers know about like all infrastructures, about bridges, buildings, everything, but they look at it mostly from the environmental and the structural perspective there. But for our students, we only focus mostly on the building side. The same thing with electrical engineers. They learn a lot about fundamentals, different application of electrical engineering, but architecture engineering, we only focus on electrical and lighting part of the building. So it's totally different than architecture as well. So that's also another distinction. So if you like architecture, it's a completely different path. Usually they take very few number of calcs and physics courses compared to us. So you want to be careful about this one. But also we did have a students that they studied architecture engineering and took a minor in architecture. So our school offered that. So we're taking 15 credit hours. They can take a minor in architecture, and it's a very good way because at that point you're exposed to architecture, knowing it more, and you follow the passion of architecture. But at the end, your degree is in engineering. So these are a few things that we can go through it in more detail if time permits.
So if you're going to be a civil engineer, you want to work in Miami, Florida, where you can be out on your bulldozer all the time. But if you're going to be an architectural engineer, you want to work in snowy Minneapolis where you can be in the building and it's warm.
Yeah, I mean, that's the ideal scenario, but usually we've seen that, like, if you design a building, for example, our offices here, we had to turn on the AC to make sure that we can do the recording. So a lot of times the ideal scenario doesn't happen. But yeah, definitely that's the thing. We can condition the buildings to make it comfortable.
And you've actually built a lab here. I don't know if we call it the HVAC lab, but you've built a building within a building here where you can put equipment in it and test it, right?
Yeah, the lab has been in progress to make it completed, but yeah, definitely it's an environmental chamber. We have a few other like minor lab components developed, but the idea is could we have like an enclosure that is as you mentioned, like, building within a building, separated from the building, so different airflow patterns, different, when it's functional fully, different automation systems could be applied there. So it could be used for both energy efficiency, building automation systems, and indoor air quality research, and of course, like teaching as well, because a lot of times, for example, those in the HVAC class, when we talk about ductwork, piping, all of those, you do the calculation, we see the numbers, but to make those numbers tangible, so it's always good to see a real lab, a real installation. So hopefully at some point, all of these will be incorporated in our teaching curriculum to make sure we fully have the components needed there. But yeah, the lab is going to be designed to include a few different, aspects of building systems.
And if a student goes through that, they'll know how to design the ductwork so it doesn't make noise and hum.
Oh yeah, I hope so. I mean, we talk about it, and then at some point, I mean, if our alumni are watching this, they will like probably laugh and say, like, your HVAC course, you should split it in two courses because it's a lot of content there. So even with the way we cover it at the moment, we try to make sure ductwork don't make any noises, or we don't see a drafty room. But I'm sure we are missing a few things could be added in elective courses later.
Yeah, I was involved in a forensic investigation one time, many years ago now, where the ductwork was humming, and it turns out that the HVAC contractor intentionally put in thinner ductwork than the standards were to save money, and it was a federal building, and because of the noise it was made, and when we figured out what was going on, the feds came back and actually took this guy into criminal court for putting lightweight ductwork in the building. That's where I learned ductwork will hum.
Yeah, I mean, hopefully, we have the goal of offering the commissioning class at some point. So maybe at that point we offer it, and then we can catch these early on in the process there.
It sounds good. Um, but I know some of the research you've done, which I found kind of interesting. Well, I find much research interesting, but you were going into people's homes for the Veterans Administration. Is that correct?
Yeah, we do have a big project that has been almost in supported since 2020 2021. The funding comes from Housing Urban Development, but we work closely with our colleague at the VA. It's been a large project, so we have 80 basically participants, and these veterans are part of the study. The idea is we want to see how air cleaners or air purifiers could help these veterans with COPD. So we go to their homes, install these air cleaners, and we have two different types. One of them, we call them active, meaning the real air cleaners. The other one are the sham or placebo ones. Like they are the same, they weigh the same, but they don't have the filter on. And then we work closely with our colleague at VA, Jesse Brown. These are experts, physicians, and specialists there. They look at their health data. We call it the baseline, meaning when they start the study, usually takes almost a year and more than that. And then we call it end line at the end. So we look at their health symptoms at the beginning, at the end, and we want to make sure we look at the air quality in these homes and understand how the air purifiers would help them. The study still is in progress. We are done with the going to the homes, collecting data, and we are in the final pieces of putting everything together to have the outcomes and report it back. But it's been a major project, going a few times to homes. We had 80 participants around the Chicago area, and it's been rewarding, I would say, knowing about veterans homes, how we can help them, and hopefully the outcomes will come out soon so we can share with public and with the VA colleagues and veterans.
That one just to me seems to be a very interesting uh, research, because so often in universities, somebody will get a research grant and they'll sit right there in a laboratory and do whatever it is they've got the grant. You're out in the real world here. That particular one. Speaking of the real world, the students in your program, uh, could you talk to me a little bit about some of the internships?
Sure. I mean, one of the good things about being in Chicago is we are almost like 10 minutes from downtown area. And usually our students have been very successful in securing internships after their even like sophomore year. We even had some after their freshman year. A lot of them work with AEC companies there. They work on the design, they work on drafting, different like companies and design firms in the Chicago area, and that's definitely helpful for their education as well. Like a lot of times when we, for example, when they come to the HVAC class in their junior year, I would say half of them already know Revit. And I mean, even though if I offer Revit trainings, they don't need it because they learn it through their internship. Having internship is always good, and usually I would recommend students to maybe try two or three different type of internships, because if you're in architecture engineering, at some point you could be focused on structure, at some point you might be focused on construction management and engineering, or at some point you might be interested in mechanical systems or like fire protection and plumbing, all of those. So doing a few of them will give the students a little bit opportunity to think about their career. At some point when they reach to their senior year, it's like, oh, I did one internship in structures, I did one internship in like mechanical systems, but my passion is more on like maybe a combination of those, or maybe just purely go to the mechanical systems or structures. But I would say almost all of our students by their senior year at least they tried one internship, and it's been very enjoyable, because a lot of times when we have meetings in downtown area here or going to other meetings around, we'll see a lot of our former students and alumni either there as like full time, or sometimes our current students and intern there in the offices. So it's like we spend a few minutes to chat about like our programs in general. So I would say like we are doing well and students are doing well, and it's one of the strong things about our program that we are all proud of that.
And, and I might add that most architectural engineering programs are administered by schools of architecture, and ours is one of the few that's really administered in the engineering side of the house, and as such tends to have a much more focused scientific approach to what's going on. I think that's why you got the Ph.D. program in place, would you say?
Correct. Yeah, we have about like 25 to almost 30 architecture engineering programs in the US. Some of them have their own department, very few of them. Some of them are part of the College of Engineering, and some of them are part of College of Architecture. Depending on the strength of the institution and the program, the focus could vary. Like for example, some of them, as Professor Lemming mentioned, they're heavily focused on architecture, so they have more studios. Also, some programs, even if they're in the College of Engineering, they might have more structure focus, so they offer more structure courses. Some might offer more electrical and lighting courses. For us, I would say our program is like fairly balanced. So we look at all kind of disciplines in architecture engineering, looking at construction management and engineering. For example, we have the cost estimating and the scheduling that Professor Lemming offers or used to offer some of them. We have structural design courses. We have building mechanical systems. So I would say our program is fairly balanced. It's a 4 year program. Some programs are 5 years, a little bit longer than the others. Um, but our program, you'll get exposed to different one. And one other element that I would say some institutions offers, also we do have it. We used to call it co-terminal, or now the name is changed to plus one, meaning with spending another year here, you'll get your Master of Engineering. One thing is very common to see for architecture engineering students is like they say we like buildings, we want to get the engineering part of the buildings right, but at some point we want to get our specialty, meaning for the master's degree we'll focus more on different aspects. So some will do structural engineering, it's like their undergraduate is in architecture engineering, staying another year longer, with also transferring some of the courses, they will be able to get their master's degree. So like they will be a structural engineer. Some of them will say like, whatever I learn in architecture engineering, I want to focus more and I want to do it more in the building system side. So they will get their master's in architecture engineering. Or some of them will come to a program that Professor Lemming is the director of the construction management and engineering. If did I get it correctly?
Yeah, yeah. Construction management's the master's program. We've restructured that just in the last couple of months, to uh, actually combine several of the master's degrees in civil in the CAE department, and in so doing, we just realigned a few diverse civil degrees under different academic codes and how that all works. So, but the construction management is now, it used to be a master's in engineering, now it's a master's of science.
Got
So
it.
it's
Yeah.
the MS, and CN. But we've also added the bachelor's degree, which has just been approved by everybody. I saw the final web page yesterday, I think. So we're coming out the gate with that in a week or two.
That's wonderful.
But yeah, we do that. So I got a term written down here I was going to ask you about, and that's ASHRAE. And all professions have professional organizations, whether it's civil engineers with the American Society of Civil Engineers or anything else like that. And ASHRAE is the professional organization basically for building systems, and we've done a lot of work with them, and some of the scholarships we've gotten for our students and that you've gotten through them. Uh, just talk about how ASHRAE fits in to what you teach, and how it's part of the profession.
Sure. Yeah, that's one of the organizations that we rely heavily in our curriculum to use their standards. ASHRAE used to stand for American Society of Heating, Refrigeration, and Air Conditioning, but at some point it grew globally. So right now it's just a name. The acronym doesn't stand for anything because we want to make sure we're inclusive there. I've been involved with them. Very fortunate. Like when I started my master's degree, I received the ASHRAE graduate grant in aid, which has been very competitive, and I was very fortunate. So I got exposed to ASHRAE, knowing more about them, and then as part of my study for the master's and Ph.D., got to rely on their resources. And I've been fortunate as like a faculty also receiving their new investigator award, which is one award per year to the faculty. We are, I would say, probably one of the few programs, or maybe the only one, that the two like full-time, tenured faculty have received the new investigator award as a faculty. My colleague here, Brent Stevens, also received that one. So very supportive. One of the things I like about ASHRAE, similar to other organizations, like similar to ASE for civil engineers, have been supportive of students. Like if you're a student, you have the option to apply for their undergraduate scholarship. They do have a graduate scholarship. Also, the ASHRAE local, ASHRAE Illinois, has been very supportive of our students. I would say out of like 4 or 5 per year awardees, almost 100% of them, or maybe 3 out of the 4 or 4 out of the 5, are from our program. So this is the way I would say like students get very motivated to learn about ASHRAE and how they could get involved. The other thing that we heavily use in our curriculum is the standards and guidelines. For example, when I teach HVAC system design, or if my colleague here, Dr. Stevens, offered the building science course, we heavily rely on the ASHRAE fundamentals. So rather than having like a textbook, because a lot of the content we talk about comes from different resources, so we rely on a handbook. So the main reference for these courses are the ASHRAE Fundamentals Handbook. Like for the ductwork design, we look at how the ductwork should be designed. The same thing with piping. And then at some point, if you want to look at the minimum indoor air quality requirements, we look at actually 62, point one for commercial buildings, for example. Or if we are designing a building, we want to look at the minimum requirement for energy efficiency. We look at ASHRAE standard 90.1. So these are a few different ones that we also use in our program. But I would say, if you're in architecture engineering, especially in the mechanical systems, you will definitely want to be involved. And I would recommend all students to be involved at least with one professional organization. You want to pick the one that you feel that aligns with your interest and get involved with that, because at some point you start maybe from a student member, you get the benefit of that membership, gradually get more involved, and then at some point you can also be involved with the technical committees. I've been involved with a few actually technical committees, chairing one of them, and it's really amazing to see how you can work with colleagues from industry, with design firms, with academia. So you'll get different perspective, and it's not just like purely you're an academic person. You get different perspective when you're like looking at different problems or different challenges that you want to find the solution for that.
So, well, let me ask you a little bit of a loaded question
Sure.
here. In the press, huge thing nowadays in the last 6 months or so of NIMBY, not in my backyard, for data centers. People seem to dislike data centers, but it seems to me that the data centers would make great use of architectural engineers. They're talking about the cooling
Hmm.
and the electricity use and a whole lot of things like that is why nobody likes them. Uh, I can't find any other reason why they don't like them. Maybe there's a few I've missed, but it seems to me that that bailiwick is actually yours. So talk about an architectural's role or the architectural engineer's role in building data centers.
I mean, it's, as you mentioned, it's been like a growing part of what we hear or see in our daily life. Also, like the implication of data centers. Maybe at some point we can talk about AI being used in classrooms and teaching all of those. But yeah, it's been part of what we look at it. We hear from different perspective there. One thing I would say, data centers, similar to other technologies, will learn how to design them more efficiently. I know some campuses actually are thinking or have implemented already using data centers, the heat being rejected there for heating the campus. So this is a solution, as you pointed out, Professor Lemming. We can use architecture engineers to say, okay, this is the amount of heat rejection coming from the data centers. This is the requirement to cool them. How can we optimize it? Because at some point you want to heat up your campus, like for space heating, or maybe you want to heat the water for the water heating there. We'll learn how to incorporate all of these. I would say it's part of the learning process. A lot of times technology comes, we learn to optimize it, we learn to make sure that the side effects are minimized, and of course at some point it's like combination of different factors. You want to work with different disciplines there. Maybe that's one of the things, as on a daily basis we use AI, we may want to be more careful. Like any thing that you ask AI means at some point you're relying on the data centers, meaning more heat is being generated. So that would be something maybe we could all be cautious and conscious of that.
And how is AI creeping into your profession?
This is a very good question. I would say we are still learning about it from all, all perspectives. If you are working in industry, if you're using AI, the question is how do you use it? If you have you're signing or stamping that, how do you trust the AI there? I can talk more from the perspective, in the teaching perspective, also even research. Those who are using AI, I would say writing codes has been much easier with the AI right now. Like you can basically get the code that you used to spend days in a few minutes or even not less than a minute, especially if you know what to ask for it. So that would be something has been changed a lot significantly. One thing I would recommend, especially like those who are currently studying it, because Professor Lemming, I, and others, we had the luxury of seeing the pre-AI kind of things and post-AI or like doing the AI. So we learn about the fundamentals, we learn about the basics, like programming. I remember I used to spend a day to debug a code just and then finding out maybe with two-line changes that fixes the issue, especially if it's a big code there, a programming code. But right now, I'm sure like the AI can catch that within a few seconds or minutes, depending on the source of the problem there. But those who are like in school at the moment, you want to be careful of how you use AI. Maybe get you the answer, maybe sometimes give you the wrong answer. A lot of times you might see the right answer, but learning about how to use it is important because at some point you have to go back to the basics. You have to make sure you double check that number. Like, for example, Professor Lemming, if someone has a PE and using heavily AI, at some point you have to stamp the document, correct? Like,
Yeah.
I don't think we still know how to deal with that. At some point, the responsibility it's on that person, correct?
Well, in my as I've been looking at this quite a bit in the last 2 years or so, one of the distinctions I make is historical information. It can synthesize and bring me stuff very quickly, which might take me, well, in the old days of the slide rule, it might take me 2 years to figure out the, these forces in the Sears Tower. When we got strudel and mainframes, we could do that in a day, and maybe we're down to 10 seconds in that. But the subjective decisions, the decisions that we have to make as we look forward. So I've kind of gotten this thing with AI is it's good for looking back
Mm-hmm.
and pulling in what I need, but looking forward and having to take different options, it can't make those kind of choices yet, at least. You need a human being to say, I think this is what we need to do. I think we need, uh, whether it's electrical chillers on electricity or chillers that run off of a steam plant, as an example.
Mm-hmm.
Just when I worked at the district, I found out that our air conditioning was all steam operated, which
Sure.
I found intriguing. So, but making that decision, and uh, so that's how I've seen AI. It's a good tool, but you still have to take responsibility. Now, the lawyer in me says uh, the problem with AI is you can't sue it. You need a human being to sue. So
Sure.
it's the same answer that I just gave from a different profession.
That's true. Yeah. I mean, at some point, I think it's just learning about like your responsibility of using AI become important because at the end, if you're a student, if you're like a faculty, if you're in industry, at some point the responsibility is on you when you're using these numbers and like the AI. So learning about that, learning about like fundamentals, I think still there's a huge value there because at some point, as Professor Lemming mentioned, there are things that the AI may give you an answer, but the answer may not be correct because it doesn't have sufficient data to back that up. But if you know the logic, if you know how to train it, you can be empowered and getting better results and probably more accurate result than maybe getting a result that may not be accurate.
Well, and yeah, I will add on the AI, and I did this last semester in one of my classes. I tried a different approach, and in that class, I told the students for a project, I want you to go to AI and do this project, and once it's done, turn it into me, and then I want you to take the project and go through it and show me how you fact checked it, and you checked the equations, and you made sure that what the AI gave you was right. Because I think in the real world, if you're going to stamp a design, that's exactly what we're going to have to do. That's how I looked at it. And that worked out pretty well, really. Uh, I had about 10% of the students who couldn't figure out how to do it to save their souls, but the other 90% really did quite well on the markup phase of going through and saying, this doesn't make sense, this isn't right. I would adjust it this way and that. And I think as professionals, as you said, we stamp the plans. We take responsibility. And, uh, and in that regard, again, that's how I've kind of come to look at it as the AI is great looking back, but it's not very good in subjective, forward looking decisions. It can't make a decision, it gives you options.
Sure. Yeah, I think that's well summarized. Definitely, I mean, having those kind of assignments and training in different courses, programs, the same thing with industry and other disciplines is that could help to make sure AI is being used correctly because at some point it's like technology similar to calculators, computers. So we want to use it, but we want to learn how to use it. Like, for example, like the AI summary that when you type something, the AI give you a summary. A lot of times, if it's a simple thing, the summary is correct, but I've seen a lot of time that summary may not be accurate. It's like with some specific assumption, give you a number. But Professor Lemming and I, we have been like in a generation that we had to read the documents and find that number ourselves. So we might able like say easy like, oh, this number doesn't make sense. Let me go to the source and then you find it out. But the generation that didn't grow up with like before AI, pre AI, that would be very difficult for them because that's a new norm. I think we want to make sure that we show how the new norm is and how can we improve it to make sure they can do the fact checking, doing the quality control and quality assurance for any numbers they see there.
I, I, I find the AI itself is wrong about, I don't know, 25 or 35% of the time. That it's pulled some data out, but that data is not applicable to what we're working into that. And I've gotten to the point where they'll give me an answer and I'll tell it, says, your answer's wrong. Well, then it says, well, why is it wrong? And I just about died last week. I told it why it was wrong, and it says, just a minute. And then it spun around for a while and come back and says, you're absolutely right. That was in deep storage in different locations, and my initial look at things only looks at things that are recent in the last 5 years. When I went into the deep storage, your position on that item is is, is exactly historically correct. And I thought, boy, what a mealy mouth answer.
That's amazing. Yeah, I mean, the AI is like similar to other technologies will like definitely minimize that gap. Like when it came these large language models like 2 3 years ago, I remember a lot of like our like TAs and students wanted to test it, so get some of the assignment numbers wrong, and now it's keep getting better. At some point, the gap will be minimized, but it's still there will be a gap there. You'll see those situations. One thing else I think it's important for the AI use is like the copyright. A lot of times, if you have a document, for example, standards or even lecture notes from the classes. I mean, if you're putting all of those into the AI to give you a summary, that's basically you're violating the copyright of like the course you are teaching. Those course materials, like Professor Lemming had like 38 years there
Yeah.
to have all of these materials assembled in the teaching format and then like easily just putting in the AI. There's a copyright violation there. The same thing with like documents. A lot of documents are sensitive. Like if you're a student, maybe less sensitive, but later on when you get a job, a lot of them you're not even allowed to share it with anyone or anything. So these are the things I think we want to make sure that our students like get to know the importance of them.
So, uh, something else I kind of wanted to talk to you about. Uh, in We've been talking more about really kind of heating and cooling systems here, but the reality is that as buildings have evolved in that, and these companies like Siemens, Siemens is the one I think of, Johnson Controls, and these a few of the other big names in the business, they've branched out into everything: security, doors, fingerprint readers, and closed circuit TVs, and facial recognition, and that all seems to fall in you guys' bailiwick. Is that correct?
Correct. Yeah, like looking at smart buildings. This is a good bridge between what Professor Lemming and I usually we chat and talk about it, like the cost estimating course that you offer, the CA 470. It's a good bridge of looking at all the different divisions there. But it comes mostly to architecture engineering, especially if your specialty is more on like building systems, building automation systems. um, Buildings are moving toward that, but also we want to be careful of not leaving buildings behind. There's still a lot of like if you look at city of Chicago, a lot of our buildings at the moment don't have any kind of automation systems or even any cooling system. Right now, we're expecting a heat wave later this week. So it's very important to acknowledge that we want to be careful. Like, yep, smart buildings are coming, especially for commercial buildings. We can integrate different, systems there, from the cooling and heating systems to the lighting systems to the shades to like the building basically door. All of those they could be integrated into one platform, and we are moving there, but also we have to acknowledge that there's also a huge disparity between like smart buildings versus our common buildings on a daily basis we use. And a lot of times I would say, especially looking at residential buildings, you might have different elements of that, but they don't talk to each other. You might have like a smart thermostat, you might have a smart refrigerator, but they don't talk to each other well. At some point, I mean, you can engineer it to talk to them to talk to each other, but it's very complicated, and you need a little bit more advanced kind of understanding of the systems there. So we are getting there, and I think architecture engineering, as Professor Lemming mentioned, is a good disciplines to work with other disciplines here, and it's doable. Yeah.
So I think I covered almost everything. Is there another research besides the VA research that you think is really kind of cool we did that you want to mention, or this is the free for all question?
Sure. I
Did I
mean,
what did I forget in what you're doing? When I was in law school, my litigation professor said when you talk to a client, the last question you say to them, "What is so basic about your business that I didn't ask a question about?"
it's a very difficult question.
An interesting
Yeah.
question, but yeah.
Yeah, I mean, I've had like almost like, more than 25 different research projects, working with great collaborators, colleagues, students. Um, I would say it's like, similar to when you have like, kids. Like I would say all of them are good. I'm glad that we were able to talk about one of them here. We talked about the program, which is good. I'm very proud of our like students, alumni here, and the program and the great work that we are doing here. A lot of times, our students after graduation, when we talk to them, it's like, what part could be improved when you went to the program? They all say like, we were prepared for the job market. I mean, it's a combination of doing their internship, taking courses, studying, having great colleagues here. But very proud of our students. And one of the reasons I would say that we are probably all here teaching and in being in the higher ed is we are passionate about teaching. We are passionate about supporting our students and the next generation. I love research, but also I love teaching. So I think they both come together. Some could be purely focused on research or teaching. For me, like the bridge here would be good. I like that a lot of times we talk about different disciplines together. Hopefully, at some point, we can co teach a course together. We had that idea. I know you wrote one or two chapters for the book that
Yeah,
we
I
are
got the
writing.
first two chapters of that book. I think in the spring. I think we're going. I was hoping we'd schedule it this fall, but I really would like to do it in the spring. I think we got some reorganization going on in that. We need a little bit more breathing room to get the commissioning course out.
True, true. Yeah, I mean, that's been something we have been looking at it. I would say, like, one of the good bridges between what I do and Professor Lemming do is like the CA 470 that Professor Lemming has been teaching it for 38, No,
38 years.
38 years.
This fall will be 39.
That's amazing. Looking at different divisions there, I always learn new things there. I love the discussions there. I like how like reading drawings, understanding like building drawings is incorporated there because that's the same thing that we try to do that in different courses for the HVAC systems. We look at drawings to understand ductwork and piping, and then at some point adding some changes to there, and then at some point, like students design it and draw it themselves. Unfortunately, we don't get to like the building automation system part, but I understand you cover that extensively in the CA 470 there.
We do.
So these courses and part of the program are complementary here.
Well, I think we've covered most of it, but what I forgot to do was throw my 60-second commercial in dead center in the middle of it. So I'm going to throw the 60-second commercial on our department, the civil, architectural, and CAE. Yeah, civil, architectural, and environmental engineering. And I know my producer here will throw up the titles at the bottom if you want to find out more about any of our programs, and you can he'll be throwing that in there for us. And don't forget, we got this new bachelor's program coming in the fall, and which we've talked about before. So we're a full service construction and engineering university here to build buildings. I'm trying to read a cue card here, and I can't.
Yeah, for the classes. Yeah, I need to. I wore the glass so I could see the suggestion here, like for the classes here that I offer. I think can I add a little bit more promo here?
Certainly.
One thing I would say is like don't forget to subscribe to Professor Lemming's channel. I know like especially Professor Lemming work hard to with our producer here. Can we name the producer?
Yeah, you can. It's fine with me.
Pedro here is the producer, so I think don't forget to subscribe to the channel. Professor Lemming and Pedro here work very hard to make sure that this podcast is running and getting different perspective here. I appreciate being invited here. I know probably last week I was here and then my professor like you're the only one in the building, maybe one of the few. Do you want to do it? It's like yes, I'll do it. But I also I want to talk a little bit about our programs and classes here as kind of 60 minutes, 60 not minutes, seconds advertisement here. I teach thermodynamics, energy conservation. We look at energy modeling and retrofitting of buildings. I teach HVAC system designs. At some point, offer the building automation system, co-taught the indoor air quality class. I help with the capstone. Also taught the CFD computational fluid dynamics course at some point. So there are a lot of good courses in addition to the one I teach here that our colleagues are offering. So I highly recommend our undergraduate programs in architecture engineering. We do have the master's and the Ph.D. as we talked about it. We also have some certificate programs. For example, we have a certificate in architecture engineering or certificate in building energy modeling. Those are usually 3 courses, 9 credit hours. So with that, you can get some exposure to the program, especially for professionals who want to do continuing education there. And then at some point, if you're interested about those topics, you can convert that to a master's degree for a graduate program. I believe there's also something similar for construction management, correct?
There is a certificate in construction management that we've had for years. Basically, I think 4 courses. And it's funny, the people who have taken that, I have had 2 traders down on the Chicago Merc that wanted to get out of that and get into construction. One of them because he met the love of his life, and the father owned a construction company in Pennsylvania and said, "Kid, you're not marrying my daughter unless you come to work in the company." So he took our courses and got qualified to go there and started out actually in a paving crew on that job, but or that company. But one of them was a police lieutenant who had been in gang crimes and decided he wanted to get in something a little safer than gangs in Chicago. So he got into the construction business, which I'm not too sure, but so it's some interesting people we've had, and we get them into it. They do well. They feel okay. Then we get them on through the masters.
Yeah, well said. It's a very good program for changing career path there. Um, Also, I would say, like, each of the programs, if you see it online, there's always a contact person. Or if you don't know the contact person, reach out to the admission office. Or even, like, I would say at some point, reach out to faculty or stop by. We would be happy to explain. And also, I mean, when prospective students with their parents come here, I feel like look at all different programs and institutions and make the best decision. But I'll try to give them what I like about being here, what I think our program is strong about, and sometimes also what are the things could be improved there. So we would love to hear more. So feel free to drop an email to us or stop by at some point. Happy to chat. So we did more advertisement than we
So
should.
we thought,
But also,
it's midsummer. People are bored. They want to hear it.
yeah, I have to go back to my office and work. So this is good. We're chatting here. So let's keep
You're putting
keep
it
going.
off, huh?